The frequency of the first harmonic of a standing wave on a wire is f. The length of the wire and the tension are both doubled, so length and tension are doubled. What is the frequency of the first harmonic as a result? Okay, so let's think of the equation that we have to use for this question. We can consider v is equal to, so wave speed on the wire that is equal to root t over mu. And the wave speed we know is equal to frequency times lambda. So if we consider the first harmonic, which looks like this, if this has a length of, let's say, L, this here is half of a wavelength. What we have here is half of a wavelength. If you were to continue this line like this to here, then this now represents one full wavelength. So for the first harmonic, one wavelength is equal to 2L. So first harmonic lambda is 2L. The wave speed then becomes frequency times 2L. Put that into this equation up here. We end up with 2FL is equal to root t over mu. Okay, we're looking to see how the frequency varies in the question. That's what it's asking us to do. How does the frequency vary? So then we can rearrange this for frequency. Frequency is equal to 1 over 2L times root t over mu. And then we can think about proportionalities. So what's changing in this case? It says the length and the tension are both doubled. So length gets times by 2, tension gets times by 2. The mass per unit length, which is what we have here, that shouldn't be changing. That should remain constant. It doesn't say anywhere that the density of the material or the cross-sectional area has changed. Those are the things that affect the mass per unit length. In reality, if you increase the tension and stretch out a wire, its mass per unit length will decrease slightly, but generally you ignore that for these kinds of proportionality questions. Okay, so we know that length and tension are changing, so then this equation can then be rewritten as frequency is proportional to, so changing it to a proportionality, root t over mu, root t over L. The 2 and the mu are both constant. 2 is constant, mu is constant. And then if tension and length are both doubling, then frequency, you just replace the t and the L with 2. Frequency will then get multiplied by root 2 over 2. So if we go up to our options, root 2 over 2 is not one of them, at least not directly. So this can be rewritten, the root 2 over 2 can be rewritten. Root 2, or rather 2, is the same thing as root 2 times root 2. Because root 2 squared is just 2. This can then simplify to 1 over root 2, just cancelling out one factor of root 2. So therefore, the frequency is multiplied by root 2 over 2, yes. You can also write that as being multiplied by 1 over root 2. Same thing. And 1 over root 2 is what we have for option A, so that would be our answer.